So in this video, we're going to look at direct variation. We're going to look at what direct variation is, how we can actually find if something is a direct variation, and then finally we're going to finish with a real life question. Okay, so the first thing we need to talk about is what is direct variation? What are we talking about if something we say is got a direct variation? Okay, so we are talking about when we have two quantities and the ratio between them is constant. So what I mean by that is, for example, let's say I said I have one apple, okay? And I said this costs £5, okay? Well, if I buy two apples, this is going to cost me £10. If I buy three apples, it's going to cost me £15, and so on. So I know this is a constant of variation because the ratio between these two quantities are the same. So 1 to 5. This would be 2 to 10, which I could simplify to 1 to 5. This would be 3 to 15, which I could simplify to 1 to 5. And you will notice that the ratio is the same each time. That is what we're talking about with direct variation. It doesn't matter how much of something you have. If you wrote it as a ratio, you would get exactly the same. It is constant. Okay, so now let's look at a little bit more detail of the equation. So when we talk about direct variation, we have the equation y equals kx. Okay, it is the same as y equals mx. The k and the m, we are still talking about the gradient or the slope. We're talking about what something is increasing or decreasing by. It is the same. Okay, but instead of saying y equals mx plus b or y equals mx plus c, we don't actually have that at the end. So it has its own name. It is a direct variation. So the k is what we call direct variation. And there's a reason that we don't have the plus c at the end. And we'll look at that a little bit more detail in the next question. Okay, so let's have a look at the direct variation graph to begin with. Okay, so we have this graph, we have this equation, y equals 2x. So it's in the form y equals kx. So if I'm going to graph this, there's plenty of ways to graph. You can look at previous videos that I have posted. I'm going to just use the rise over the run. Okay, so just to remind you, rise over run. In this question, because the k is 2, I can write that as 2 over 1. So that means I'm going to rise by 2 and then I am going to go to the right by 1. But it doesn't have a y or x intercept. So we need to think, well, what does that mean? Actually, that just means we have a plus 0. But we would not write the 0. That's why it would be direct variation. That means that we start the graph from the origin. So direct variation graphs intersect at the origin. And then I can just do the rise. So rise by 2, run by 1 because it's positive. Rise by 2, run by 1. And that is my direct variation graph. So that's the first thing to be aware of. It intersects the graph at the origin, which is 0, 0. And then just to be aware, in this question, if I'm talking about the actual k in this example, we can call it direct variation or the constant of proportionality. The second thing that we're going to be aware of then is how can we actually determine if something is direct variation? How can we prove it? Maybe we don't have a graph. Maybe we are just given some values. Okay. The first thing you might think of is say, okay, if I graph this, it should intersect at the origin, which is perfectly fine, which is right. But I'm going to show you a different way how we can do this. Okay. So at the beginning, I was talking about the ratio between the apples and the cost. And it should always be the same. It is constant. Well, it's the same if we have some information here. The ratio between them should be the same. And a way to compare this is I'm going to do y over x. And they all should be the same if I write it as a fraction. So if I actually check this out, I have 1 over 2 is the first one. The second one is going to be 2 over 4, which if I simplify is 1 over 2. The next one is 3 over 6, which if I simplify, so divide both of them by 2, I'm left with a half. 4 over 8 becomes 1 over 2, and the last one is 5 over 10, which is also 1 over 2. So if we look, that fraction, if we simplify them all, is the same, which indicates this is constant of proportionality. Okay? Another way you can think about it is, if I ask you to work out the slope using this, so remember the slope formula is y2 minus y1 over x2 minus x1, you would still get the same answer. So if I picked any two of these, I could do the first and the last. So 10, no, sorry, that's x. 5 minus 2, nope, sorry, that's wrong again. I could do 5 minus 1 over 10 minus 2. I'll be left with 4 over 8, which is 1 over 2. That would be my slope, which in this question would be my k. So essentially, the equation is y equals a half x. If it's direct variation, which I've proven, it doesn't have any x or y intercept in terms of it passes the origin. And I can back this information up by actually graphing this information. So even though all the ratios are the same, I'm going to take this information and I'm just going to graph all my ordered pairs. So I can go 2, 1, I can go 4 and 2, I can go 6 and 3, or I can even graph this using the rise and the run. But if we graph it, it intersects at the origin, which also proves it's a direct variation. Okay, so they're the two things we've looked at. We've looked at the equation, just graphing it, crosses the origin. And we've also looked at how we can just use the information from a table. If the fractions are all the same, it is a direct variation. What we're going to do now is we're going to look at questions when we don't have a graph and you just have some information and you have to solve a problem. Okay, so this is a typical exam question. Y varies directly to x when y is 12 and x is 3. Find the value of y when x is 5. So there's two parts to this question. The first part is it's giving me one of the ratios. It's telling me that it is direct variation and it's giving me basically an ordered pair when x is 3 and y is 12. So we can just use the equation of direct variation, which is y equals kx, because we already know this. We've already been taught this. And all I have to do then is say, okay, well, if it's direct variation, I have to work out what k is. What is the constant in the equation? They've gave me an ordered pair. So 12 equals k times by 3. Divide both sides by 3. And we get 4 equals k. So this is the constant of proportionality. So don't forget to write the equation. So it is y equals 4x. So that is the equation for this question. So that's part 1. Part 2, the question has asked, can you find the value of y when x is 5? So we just use that equation. We don't have a graph, we don't have anything else, but I'm going to use y equals 4x to work out what y is going to be. So y equals 4 times by 5, y is 20. And all that means is if I graph it, it will go through the ordered pair when x is 5, y is 20. And this is an exam question of a direct variation. So let's finish on a real life question then. Okay, so what happens if we're given a real life question about direct variation? So the money Oliver earns, M, is directly proportional to the number of hours H he works. When Oliver worked 15 hours, he earned £67.50. So £67.50. The question wants us to know how much will he earn if he works 27 hours. So it's similar to the last question, but it's just giving the variables a meaning. Instead of y, they have m, and instead of h, they have x, they have a h, but it's the same thing. So the first thing I'm going to start with then is looking at what they've gave me. So they've told me when he earns £67.50, he worked for 15 hours. done it in the wrong way, sorry. So when he works for 15 hours, he earns 67.50. So that's the first thing we need to look at. So M equals KH in this question. So they've gave me a value. So 67.50 equals K times by the number of hours that he works, which was 15. So all I have to do is divide both sides by 15. And in this question, the K actually represents the rate per hour. And that's what we're trying to work out. So if I actually work out what 67.50 divided by 15 is, we get 4.50. So it's £4.50 per hour. Don't forget to write the equation. So the money he earns is £4.50 per hour, which we would times it by H. And this is the equation. The question wants to know, well, now that we know how much he earns per hour, how much money will he make if he works for 27 hours? So we just substitute that in as H. So M equals 4.50 times by 27, and the money that he earns is £121.50. And that is a real life question about direct variation. So direct variation, if you graph it, it intersects at the origin, 0, 0. And if you need to know if something is direct variation, we know that it is constant each time. So when you're comparing the two quantities, it should be constant each time.